In the previous video, I spoke about resolution of vectors. So resolution of vectors is basically splitting a single vector like this into two vectors on the x and y axis. So now we have two vectors, but we don't know the resultant vector. So I also spoke about addition of vectors. So in this video, we'll be doing addition of vectors, but only for the magnitude. The direction, we'll leave it to the next video. So without any further ado, let's get started. So now let's take two vectors. Let's call this vector as b vector and let's call this vector as a vector. Alright. So due to the parallel shift which we can do, we can manipulate this b vector right here to come right here. Alright. So we got this as well as b vector. Again, by parallelly shifting the a vector, we get our a vector here. So we've got ourselves a parallelogram with just two vectors. But now, let me just erase this b a bit. Oops. Okay, let me just reconstruct it. Alright, so now that we've got a parallelogram here, we can drop a perpendicular to come like this. So we get a 90 degrees here. Alright, so since we get a 90 degrees here, if you're getting where we're going at, we are going at trigonometric ratios again. So this is b vector. So let's see what sine is. Sine is opposite by hypotenuse. So if you're seeing right here, this entire area, this is the hypotenuse, right? So let me just put it here. Sine, and yes, there's a theta being formed here. So that theta comes here as well. So sine theta equals opposite by hypotenuse. The hypotenuse here is the b vector. So b vector sine theta will give you the opposite. So this is b sine theta, right? Similarly, let's look into cos theta. All right, so this cos is adjacent by hypotenuse, and since this is theta, this will become adjacent. So now we'll come back to cos theta is adjacent. We don't know adjacent, let's leave that blank, by hypotenuse, that is b vector. So b vector cos theta will give you the adjacent side. All right, so now we can say this as b cos theta, this side. So now we got this side and this side. So for the construction of our right angle triangle. Now there's one more element missing. That is, let me just erase this a bit. Yes, as you guessed it, it's the resultant vector. So the resultant vector is basically when we add these two vectors, this and this, we get another vector that goes something like this. So to calculate that, the magnitude of that vector, we are doing all the right angle triangle stuff right here. So how to get there? We have this, we have this, we have this, we have a constructed. Let me just construct this part too. So this is also constructed. So this is b vector, this is b sine theta, this is b cos theta, this is b. So we need to find the resultant vector, right? And we know this as a vector already, and this as b vector. So now let's just do some Pythagoras theorem stuff. So a vector plus whole square, nope, it is this whole square plus this square is equal to this square. So a vector plus b cos theta the whole square plus b sine theta the whole square equals the resultant vector whole square. Now, since we are not going into direction, we'll just be taking the magnitude. So this, and this. So we are just getting the magnitude now. So again, let me move this a bit. Oops. Let me add a new page. So resultant vector is whole square, of course, because it's the square of the hypotenuse. The absolute value of a vector plus b vector cos theta whole square plus b vector sine theta the whole square. Now, we'll leave this part away as of now and get to this part. This part is basically a plus b the whole square, which is equal to a square plus b square plus 2ab, right? So a plus b whole square will take a as a and b as b cos theta. So a square, we'll just keep it as it is, plus b square cos square theta plus 2 into a into b cos theta, right? This is this part of the equation, but then we need to add this. So let's just, b sine theta whole square is b square sine square theta, right? So we see that these two are common. So a square plus b times cos square theta plus sine square theta plus 2ab cos theta. So now we know that cos square theta plus sine square theta is equal to 1. I can derive that, but right now we'll just get away with it. I can make another video if you comment me to, well, derive this in show. So fine. So since this is 1, I just made a mistake. So it's b square. It's b square here and b square here. So anyway, so that gives us a square plus b square plus 2ab cos theta. This is the magnitude of the resultant vector. So if you have any questions, well, comment it in the comment section and I'll try answering them. So thank you for watching. If you like this video, like the video, share the video with your friends or whomever are interested in the stuff, and subscribe to the channel for more videos. Thank you.